All right, page 3. The first problem, number 6, is a sigma problem. And we showed in class, we had homework related to it that said sigma acts like all the other things we've talked about, and that is we can distribute it across sums and pop constants out. So the first thing we'll do is write that. We'll do both things in one step. For summation I equals 1 to n of I plus the sum of 5 over, we can just take care of that. We sum up 5n times, we're going to get the number 5n. And then we have a formula for the first thing here, the sum of the first n integers, this guy over here. We know as n times n plus 1 divided by 2, the formula that Gauss deduced as a young grade school child. And I did ask you to simplify pretty. The first thing I absolutely needed to see was that you dealt with the sigma, and we've done that. But we can do a little bit more. The 2 will go into the 4, leave us twice. The 12 and 1 o'clock classes couldn't do that. But we can do it here, so we'll do it. So I get 2n squared plus 2n, distributing the 2n out. And then I get these 5 more in, which gets me the nice answer, 2n squared plus 7n. And on part B, all we do is plug 100 in. So 2 times 100 squared plus 700, 7 times 100. And 100 squared is a 1 with 4 zeros multiplied by 2 plus 700 makes 20,700. Nice answer. All right, number 7, maybe the hardest problem on the exam. The only one that really is not real similar to a homework problem, but it is optional. Like maybe this is the one that you'll not count in your grade. So we want to have an absolute minimum at 5, which means we need 5 to be a critical point. Right? All extreme values occur at critical point. To be a CP, which means it needs to make the derivative 0. So let's take the derivative. And we get 3 minus a over x squared. And we need that to be 0 when x equals 5, so that 5 is a critical point, which gets me 3 minus a over 25 equals 0. And so a over 25 equals 3, and our magic number, a is 75. All right, there's one more little question tucked in here. What is, so we found the value of a, 75, that makes this function have an absolute minimum value at 5. Now, what is the minimum value? Well, the minimum value is whatever we get when we plug 5 in. So it's going to be f of 5, which is 15, 3 times 5. Right, here's our function. Plus our newfound value, 75 divided by 5, which is, that's a 5, believe it or not. 15 plus 15, 30 is the minimum value. So there is our magic value of a, and there is the minimum value of the function. I should point out, while this problem was phrased differently than any homework problem I assigned, we actually had a lot of problems that dealt with this function. In fact, we saw one earlier on the exam, a very similar function, the applied optimization problem. So, and at least 2 of the problems on the review dealt with functions of this form. And one more thing, I think some people were confused because there was a symbol a along with x. Well, remember, in function notation, it tells us, if we write f of x, it tells me what the variable is. Any other symbols, they're constants. So it's a really wonderful thing about function notation, like there's no confusion over what exactly is the variable. It's x. And so this a right here, it's not x, therefore it's a constant. When I compute the derivative, over here we'll treat it exactly like a constant. All right, problem number 8. So this is exactly like the ball throwing problems we did, except the acceleration. The gravitational force is different. And like I said, my research says it's closer to 5.3, but to make the arithmetic easy, I should have probably said 6 to make it even easier, but that's okay. So the acceleration, again, because it's gravity and it acts downward, and we like to think of distance above as positive, we need a negative value. And then v of t is going to be, you don't even have to integrate. You should have these formulas. If you weren't comfortable with them, you should have them written on your note card. Plus 60, the initial velocity, 60 feet per second. And s of t is negative 5 halves t squared plus 60t. And we'll take initial position to be just where the ball was released from. So how long will the ball be in the air? Well, when it hits the ground, s is 0. So if we set our s equal to 0 and solve that equation, we can factor t out. It's a super good thing to do. And I'm going to write this guy first because it's positive. I get 60 minus 5 halves t. And again, we're setting that equal to 0. We want to know when it makes it all the way back to the surface of the moon. Set that equal to 0, and we get that 5 halves t equals 60. And so 125ths, which I believe is 24 seconds. Okay, the most common answer maybe on part B was 12. That is, people wanted to tell me, here's the surface of the moon, the ball goes up, it comes down. People wanted to tell me how long it took to get here. Well, that's not how long the ball will be in the air. That will be 12 seconds. Now, you could have used the fact that, and some of you did, I think, that parabolas are perfectly symmetrical. So if it takes it 12 seconds to go up, it's going to take it 12 more. And therefore, down here, the time is 24. But 12 seconds is wrong. It's when the ball stops at its peak, not when it's still in the air when that happens. Part C, how high will it go? Well, that's the 12 seconds. So maybe we could say at its peak, velocity is 0. So we'll take velocity, here it is, minus 5t plus 60, set it equal to 0, and you can see we get 12. So it takes 12 seconds, but that's not how high it is. We need to plug that into our position function. And I told you don't need to do the arithmetic. We'll wait until we have a calculator. So the position function is right here. We'll just plug in 12, minus 5 halves times 12 squared. Plus 60 times 12. I don't remember what that works out to. And again, if you were in the 12 or 1 o'clock class, I used the same force of gravity on the moon. Didn't change the nature of the moon, but I did change the initial value here, which changed these answers a little bit, but didn't really change the math that's required to solve it. All right, there you go, exam 3.